In this video presentation, I'm going to talk about Poisson probability distribution. First, let's look at the definition of Poisson probability distribution and the criteria for this. It's a probability distribution for a random variable x, where x is the number of successes in a fixed interval with the probability p of x such that the following conditions are satisfied. The probability of two or more successes in any small subinterval is 0. The probability of success for any two identical, however, non-overlapping intervals is the same. The number of successes in any interval is independent from the other non-overlapping intervals with the same length. Any probabilities will be between 0 and 1. Inclusive, and the sum of all probabilities is always equal to 1. So how to find probability of a Poisson probability distribution? The probability of x successes in an interval of fixed length with the mean mu is given by this formula: mu to the x power divided by x factorial times e to the power negative mu. For x equal to 0, 1, 2, 3, and so on. Now e is approximately 2.718, and sigma squared for Poisson probability distribution is always equal to the mean in that fixed interval. It's common to use the Greek letter lambda to represent the mean number of the event in that given interval. So in place of mu, you may see lambda. Consider a Poisson probability distribution for a discrete random variable x with the mean of 10 on a fixed interval. We want to find probability that x is 5. We also want to find probability that x is less than 5. We want to find probability that x is greater than or equal to 5. Find a variance, and also find a standard deviation. To find a probability that x is equal to 5, we're going to use the formula given earlier. So that would be mean to the x power divided by x factorial times e to the negative 10. In this case, the mean was 10, and the number of successes in the fixed interval was 5. And once you do the calculation, we get 0.038. Probability that x is less than 5, so the number of successes in that fixed interval is fewer than 5, is the same as probability that x is less than or equal to 4. Now, probability that x is less than or equal to 4 will be probability that x is 4 plus probability that x is 3 plus all the way to probability that x is equal to 0. So once we do this calculation, the answer would be 0.029. To find a probability that the number of successes is at least 5, that means greater than or equal to 5, we're going to use the complement rule, and that would be 1 minus probability that x is less than or equal to 4. We already found that probability that x is less than or equal to 4 is 0.09. So probability that x is greater than or equal to 5 will be 1 minus 0.029. So the final answer is 0.971. Now, the variance of a Poisson probability distribution, sigma squared, is the same as the mean, mu. So in this case, the variance is 10, since the mean was 10. And the standard deviation of a Poisson probability distribution, sigma, is always the square root of the variance, sigma squared. So that will be radical 10, which approximately is 3.162. Now let's look at how to find Poisson probability distribution using our TI calculator. If we have probability that x is equal to a, we use Poisson PDF. It takes two entries. The first one will be the mean, and the second one will be the value of x, in this case a. When we're trying to find probability that x is less than or equal to a, we use Poisson CDF. And when we have probability that x is greater than or equal to a, we use the complement rule by finding 1 minus Poisson CDF, but whatever a is, we reduce it by 1. Now the TI command Poisson PDF and Poisson CDF can be located in second, vars, arrow down several times until you find Poisson PDF and Poisson CDF. Now in this example, the phone calls to the college IT help desk occur at the rate of 1.5 calls in average per minute between 11 a.m. and 12 noon on Mondays. We want to compute the probability for the number of calls between 11:30 and 11:45. What's the probability that they get exactly 5 calls, they get fewer than 8 calls, and they get at least 4 calls? The problem, of course, fits the criteria of Poisson probability distribution. We have the mean per 5 minutes, but our question is 15 minutes. So we take the mean multiplied by 3. So the mean now is 4.5 for the interval of 15 minutes. Let x be the number of calls they receive during that fixed interval of time. To find probability that they get exactly 5 calls, we're going to use Poisson PDF with the average of 4.5, and x here is 5. The answer is 0.171. To get fewer than 8 calls, that means probability that x is less than 8, which translates to probability that the number of calls is at most 7, so it would be less than or equal to 7. Now we're going to use Poisson CDF with a mean of 4.5 and an x value of 7, and the answer is 0.913. And probability that they get at least 4 calls, meaning that x is greater than or equal to 4, we're going to use the complement rule. If we want 4 or more, that means we don't want 3 or below. So we're going to subtract that from total probability 1. So that would be 1 minus Poisson CDF with a mean of 4.5 and an x value of 3. And the answer for that is 0.658. I hope this presentation helped you understand about the Poisson probability distribution, how to look for important informations, check for the criteria of a Poisson probability distribution, and how to use TI calculator to achieve your answers.